right, so good evening, everyone. Welcome to our monthly APOD session. All right, as usual, we have four panels joining us in this APOD discussion or APOD presentation sessions. So today APODs is on the APODs on April 2022. And this is the fourth APOD session of the year 2022. And today's APOD will be slightly longer because we have more APODs this month. And as usual, together with us, we have Dr. Chong Huan Yu, President of Astronomical Society of Penang, School of Physics retired professor from University of Science Malaysia. And yes, Dr. Chong is famous, right? He's actively participate in a lot of outreach activities. And yeah, I guess a lot of our audience know him well. And then next we have our flower of ASP, Miss Chiu Woon Wei. She's also our assistant secretary in Astronomical Society of Penang. Yeah, and she's currently an engineer in a big multinational company, Renesas, and she's also a physics graduate, which she did her minor in astronomy. So she can be considered expert in astronomy. So if you have any questions, feel free to ask her. She can give you a perfect answer. And of course, we have our old friend Rayan, who joined us, who did not join us for quite some time, and he's back now, right? He's 14 this year, I guess, right? 14.
15
Yeah.
this year.
15. All right. 15. And yeah, for the past few sessions, he did join us, and he's currently applying to go into universities. And he's a very smart and very nice boy. So yeah, glad to have everyone joining us on the APOD today. So as usual, if our dear audience, you have any questions, right? Please comment it on the comment section in the Facebook live session below. And also you can, if you are watching us through our YouTube channel, just write it on the chat session on the left side. So let's start with the APOD today, 30th of April. It's very rare that we have the APOD in the last day. And yeah, we had it for this month. So 30th of April, I'll share my screen first. So can see my screen right now?
Yes.
Yes, we can.
Yeah, nice. So yeah, let's have a look. So it's a Messier object, Messier 44, the Beehive Cluster. So if I actually realized something for APOD, it's not that often we see a star clusters. Nebula is common, galaxy is common, but star clusters or globular clusters are less common um, compared to nebulas and galaxies. So yeah, this is the Beehive clusters, an image taken by an American astrophotographer named Drew Evans. So this is the star clusters, right? And as we know, star clusters can be divided into two main types, which is the globular clusters and the open clusters. So this is the open clusters. So an open clusters are more loosely cluster groups of stars, generally containing fewer than a few hundreds of numbers and often are young stars. Unlike globular clusters, they are more closely packed and also they are usually more old stars. So studying star clusters are actually quite important in astronomy because most of the stars in the clusters they are roughly born at the same time. So by studying the star clusters, we can actually understand through the stellar evolution theories. We can we can actually reveal a lot of information about their host galaxies, and also study star clusters can also give us some information on the distant scales of the universe. So this is the star clusters of Beehive clusters, or known as the Parasipi. All right, and it's a M44. It's a Messier object, and these star clusters we can actually observe, all right, with our naked eyes under the dark skies. So it looks like a small nebulous object to our naked eye, and it had been known as it had been observed since ancient time. All right. And before telescope was invented, all right, we actually don't know that this was a clusters, right? We just see some nebulous object until telescope was invented. Then it is resolved. It first observed through the telescope. It was resolved into 40 stars. And the nice thing about this M44 is it was actually one of the earliest object that observed by Galileo using his telescope. So the span of these clusters is about 15 light years, all right, and it covers about 1.5 degree on the sky, which is about the size of 3 full moons. And also the age is about 600 to 700 million years. Same like the distance, it is about approximately 600 light years away from Earth. So this is the star cluster. I enlarge a bit, all right. So, and we can see the diffraction spike over here, right? So the stars does not look like this, like a cross, but this one are known as the diffraction spike. Right, next we proceed to the APOD on 26th of April. The title known as Planet Parade over Sydney Opera House. And this is an image taken by Prasun Agrawal, an astrophotographer which lives in Sydney. All right. So this direction, looking towards the opera house, this is the view of the opera house from the west. That means from the west we are looking towards the east. So yeah, we have 4 bright planets over here. They are the Jupiter, right? You can see Jupiter. On top of Jupiter are Venus, and then above Venus we have Mars and Saturn. And yeah, the two bright things over here are the lights on the rooftop of the opera house. All right, these two are not stars, so you can see we have spikes over here, the diffraction spikes as well. So sorry. So yeah, this is an image taken before dawn. That means early in the morning. And actually for these few days in Penang we have clear skies, right? And I depart from my house to work in the early morning, and every time when I leave my house in morning I can see actually Venus and Jupiter, 2 bright stars together, quite close to each other. And in May, because the Jupiter rise time is getting earlier and earlier, so we can actually in May we can actually see that the Jupiter is overtaking Venus, right? Jupiter is overtaking Venus, and it is about less than a degree. And at the end of May, Jupiter will be even higher, will be very close to Mars, right? So yeah, as May ends, Jupiter will pass Mars as those 2 planets switch places. That means Jupiter will be slightly up here. And also, we were also able to see Mercury at the end of May. All right, and in June, the parade will briefly expand to include Mercury. That means you can see Mercury in this image as well in June. And next is 24th of April. Yeah, this is a very interesting APOD, right? So the title is Split the Universe. So before I proceed with this, maybe I'd like to give our audience and also Dr. Chong, Boon Wei, and Rayan a quick guess. So if I click on this this APOD, and then the astronaut is holding a photo. The photo will show a cat. You will see a dead cat or a lively cat. Any guess?
Give it a try. Just press anyone.
Yeah. So no. I like to get some. We have some interaction. Whether Dr. Chong, you guess you will see a dead cat or a live cat.
Before I answer the question, I want to tell the listeners and the people watching it, this is not a normal physics, Ryan. Quantum mechanics. And this is the quantum mechanical universe is what? Super weird. Very weird. So don't apply your normal intuition when you try to answer this. So you make yourself like crazy, I make a guess. That's the correct way. That quantum, the weirdness of quantum mechanics. That's what it's about. Okay. The so-called Schrodinger's cat. Yeah. So just quick, anyone, right?
Yeah. So before I click, you in this photo you will see a dead cat or a live cat.
I don't want to click.
Sorry.
I don't want to click.
According to quantum mechanics, you see a cat that is 50% alive and a second cat which is 50% dead. It can be alive.
Yes. So yes, actually currently we are in the entanglement state. That means we don't know whether it is alive or dead.
Yeah.
So that's why I'm asking you all to guess whether you will see a live one or a dead one.
Dead.
Okay, Rayan guess for a dead one, and then Bunwei.
I don't want to guess. Once I click, then no. Then I will know already.
The answer, as I said, don't use normal intuition. So the answer should be out of this universe type of answer. Out of the universe.
Yes. So let's see whether this is a dead cat or a live cat. So if our audience are watching with us, maybe you all can take a quick guess as well whether this is a dead cat or a live cat. So yeah, before I click, so let's see what happened. Ta-da! Oops, it's a live one.
Yeah.
All right. So this is actually we call it a simple experiment on the Schrodinger cat's experiment. So this is actually something about quantum mechanics. So in quantum mechanics, the Schrodinger's cat is a thought experiment that illustrated of the paradox of a quantum superposition. So in the thought experiment, a hypothetical cat, which is in this image, which is this, right? Maybe consider simultaneously alive or dead and dead, right? As the result of its fate being linked to a random subatomic event that may not occur. So let's try again whether we can get a dead cat, right? So let's see. Oops.
Okay.
All right. Now we have a dead cat. All right. So actually, there's different theories based on the Schrodinger's thought experiment. So in fact, as mentioned in the caption, you can see over here. So it says that over here, right? Some believe that your personally initiated quantum decision will split the universe into two, and both the live cat and the dead cat universe exist in separate parts of the larger multiverse. That means we are having like a parallel universe. That means, but before that, all right, this is the entanglement state. So the dead cat and the live cat exist simultaneously. So once I click this, right, then I have the live cat. Then on the other universe, the parallel universe, they have the dead cat. The others also believe that the results of the click will collapse the two possible universe into one in a way that we could not have predict beforehand. So yeah, again, let's try whether on the first click we can get a dead cat. No. All right. No. So yet others believe that the universe is classically deterministic. So by pressing the button, you did not really split the universe, but just carry out an action of predestined since time began. So in this APOD, okay, actually it's just for the sake of fun, I believe, right? The number of clicks, no matter how many times you click, all right, you did not split the universe into a lot of parallel universe or a big multiverse. All right. So that's it about APOD on 24th of April. So if you all have time and have chance, you wait.
Can you see right? Then here, I just add an general comment, right? So this is like it's either possibly live or dead, two possible scenario lah. This is a special case. The general case is by our John Everett many years ago. He proposed related to this thing, Schrodinger's cat, is that the many world theory. Many world theory. That is, for you start at a point A, and then you reach a point B. Between point, of course, this is quantum mechanics. Between point A and B, it's not one possible path. There are infinite number of paths to go from point A to B. But when you leave a point A, and finally you actually want to do it to get a B, let's say the dead cat, only this part will collapse the wave function into reality. The other possible parts will be collapsed out of the universe. So actually, the collapse of the wave function to have one reality, and the others are collapsed out. So that makes the universe very weird. So any event that we do, there are millions of possible paths, okay? But only one that will collapse to form reality. The others will collapse to form non-reality. That's what it is.
Yeah. So, sorry. Sorry. So, just a suggestion for our friends watching us from the internet, right? So, you all can just try to search for the APOD on 24th of April and take a get and try out this image, right? This is a little bit fun. And also, yeah, some background about this image. So this is actually the image of a astronaut doing a spacewalk outside the space shuttle. So this is the background of space shuttle, and obviously, our astronaut is actually holding something. All right, and this image is actually edited. This image of the cat, or this photo of the cat, is actually edited to to the to the piece of, I guess, paper or something, or cardboard that hold by the astronauts. All right, so we can have a dead cat and or a live cat. All right, it does not change. All right, so all right, that's all from me today. So next, I'll pass over to Rayan to proceed on.
A comment, Lai. So
Yep.
the now Lai introduced Rayan as about Rayan is old man. So the meaning old is not what you think. What Lai mean is old means Rayan is good in experience in astronomy. His age is young, but his experience is astronomy is experience. That's the meaning of old friend. Experience in astronomy. Okay. Rayan, you're on.
Yeah, because he joined us for quite some time, right? So yeah, so I pass over to you, Rayan.
Yeah.
Voice
Thank
yours.
you, Lai and Dr. Chong, for the introductions. Can you see one moment? Let me try to share the screen. Can you see my screen? Okay.
Yes, yes.
On to the APODs. I start here with the APOD for April 22nd. Now, what we see here is a very familiar image. Now, you may not think it's familiar because it's taken from 400 kilometers in the air, but it is something we experience every day. I'll get to the title in a moment. But what you see here is the time between dawn, astronomical dawn, and sunrise, between sunset and astronomical dusk. This is planet Earth at twilight. The image here was taken from the International Space Station's Expedition 2 crew. Expedition 2 was quite a long time ago. Now we're on Expedition 67. So Expedition 2 was relatively long ago. In fact, this image here was taken in June of 2001. It's part of the Gateway to Astronaut Photography of Earth, and it's under NASA. Now, what do we see here? Let me bring it over here. You can see that first off, there is no boundary to space. It just fades in. Now, the other thing that you may realize is this reddish hue around the clouds. This is similar to what happens during sunrise and sunset when you see the sun change its color. There is a lot of air. Let's imagine that this is the Earth here. So this is the horizon. We're standing here. Now, when the sun is right above us, there is a certain amount of air in between it, causing a certain view of the sun. But as it moves, as it changes its angle relative to Earth, when it's, say, here, there is a lot more air in between, changing the color. In this case, scattering off the blue light, and, well, all that remains is the red light that we see through our eyes. That's what gives you this hue over here. This was planet Earth at twilight. I'll now move on to my next APOD. Let's get back here. Okay. April 22nd. Yes?
Did you draw something just now, Rian?
Yes, I did. Could you see
Yeah,
it?
but no, we did not see it. We just see the APOD on 22nd. Yeah.
Okay, one moment. Let me try. Let me stop presenting and represent. Okay. Can you see the drawing now?
Yes, I can see.
Yes.
Okay. So this was
Wow.
the illustration from just now.
Please explain again the illustration.
Okay. First thing to note is that there is no distinction between the Earth here. There is no clear line that distincts the Earth and space. It just fades in. But the more important thing is the reason behind this hue, which is the amount of air, the amount of air there is between the sun and us when it is setting or rising, compared to when it's just above our head. So because of its angle, there is much more air that the sunlight has to pass through, resulting in a different hue. And that's what gives you this effect here on Earth, both from the ISS and down on Earth. Okay, to the next APOD. APOD of April 20th. A beautiful sight this is. The Robert Francis Kennedy Bridge, JFK's brother. Now, how is this related to astronomy? Well, as you can see right here, as I move my mouse out of the way, there are planets that have been lined up. These planets, similar to what Lai had went through previously, during this month, create this line above in the sky during sunrise or during sunset. Now, the image here was taken by Stan Honda. He is a well-known photojournalist with many popular images that have been republished, one of which was an image he took of a 9/11 victim, and that has been republished numerously. He worked with many popular press, and the image here was taken by him. He's an amateur astronomer. So as you can see here, Jupiter, Venus, Mars, and Saturn are lined up. Now, early in April, let me head back here. In early April, all we had were these three. It was mainly these three.
No, we do not see the change in your screen.
Oh. Can you see the change now?
No.
Okay, perhaps I should just share the Krita screen. Yes, I did. But let me just share this side. Can you see it?
Yes.
Okay.
Yes.
So in early April, it was Venus, Mars, and Saturn. In fact, Mars and Saturn got pretty close. For those of you who are familiar with astronomical terms, they were about 0.3 degrees apart. But as April entered its mid stages, Jupiter joined in, right over here. And today, 30th of April, in fact, Jupiter and Venus, yes, will be as close as Mars and Saturn were, about 0.3 degrees. And by June, Mercury will be joining this lineup. Now, the reason you're able to see this is because in our solar system, most of the planets are on around the same plane. We call it the ecliptic plane. Sure, you may have a slight degree, a small variation in the degree relative to the sun or relative to Earth, but they are almost on the exact same plane, allowing you to get views such as this. And this ecliptic plane was formed from our early solar system when the sun was first formed. Those are my first two APODs.
Allow me, Ryan, to add on.
Yes.
So basically,
Sure.
we see Saturn, Mars, Venus, and Jupiter. So to be more technical is a quadruple conjunction, 4 objects. And then you mentioned just now that Michael posted in our group that tonight Venus and Jupiter is closer than half the diameter of the moon. So if you have a good camera, you take picture of Venus and Jupiter. If you zoom loud, bigger, you can see the 4 moons of Jupiter. No. So when you see Venus and Jupiter with a good camera, you see a sextuple conjunction. Venus and Jupiter 2 and the 4 moons of Jupiter. 6 objects. Not 2, not Venus, Jupiter. 6 objects. Sextuple conjunction. If you can see tomorrow morning. Okay?
And to the audience, if you can, definitely try that. I don't have that clear of sky, so I can't exactly see the conjunction. But if you do, definitely have a look. I'm sure it's beautiful. Okay, I'll stop.
And next we have Dr. Chong.
Yeah, okay. So we go. So mine is on the 19th of April. I share now. Can see, right? Right? Can you hear
Yes,
me?
we can.
Yes.
So April 19, stars and globules in the running chicken nebula. Okay? So that's it. So remember, astronomers like to give good names. Welcome to the astronomical zoo, the Zooniverse. Okay? So we show you the picture, then I'll explain it more in detail. Wait for the picture to come. So by our Stefan Steve, so this is 19th of April. This was Stars and Globules in the Running Chicken Nebula by Stefan Steve Bonnell, astrophotographer from Germany. All right. So if I were to make it smaller now. Of course, stars are all over here. This is in the Milky Way. Globules are this thing. So when it was discovered earlier by one Dutch astronomer, Bart J. Bok, so these are called the Bok globules. But later on, they also, another American astronomer discovered Thackeray's globules. So either Bok globules correct, Thackeray's globules correct. I'll give you more information later. So this is a very nice object in constellation of Centaurus. Now Centaurus means upper part of what we call man, lower part of the horse. And I hope I'm not saying a bit more. So in 2013, we and some of the students from KL, we went to take part in the International Olympiad Astronomy Astrophysics in Volos in Greece. And we took a boat to travel around Volos, and we passed by a place called, it's a small peninsula where the name of Centaur appeared. That means the name of Centaur came from the place near Volos, where the people thought that they see this object, a creature, body of a man, lower part of a horse, going around the seashore in Greece. So that's what I call Centaurus. Okay, so now is that they call it the running, what they call running chicken nebula. Is I don't see the running chicken. You can see. This is somewhere over here.
I feel like the reddish, the orange thing is like a chicken flying. You see, the wings is up there. Yeah.
Maybe right, correct. So if this, so this could be the head. This could be the
wing.
The wing, all right, and this half dead, no, because the neck has been. So this is another running chicken. So this is the nice name given by astronomers. So this is it. And then in a sense, okay, our solar system came something like that. Right? I mean, previously, before our solar system was born, the earlier generations of stars, they died, not because of one star. Many stars will die, and when they die, not as a supernova, mild emission of this what we call shock wave throw out from the star. So all the elements of the star, from hydrogen, helium to even dust, all mixed in space, many light years, and given enough time, they will condense because of gravity, and stars are formed, aliens are formed. So we actually came from what they call this nebula, that is. And it seems, according to the research paper, from this nebula of gas and dust, only 1% will form the next generation star, an alien. The other 99% all dissipated, right? So basically, it's like this. Imagine there's a star here, and this star here is giving off, because it's young, very energetic radiation like UV light, and it's like a hurricane force wind, you know. Our solar wind is very slow, 500 kilometers per second. And it's not so dense, so not a big force. But some of these stellar wind very powerful. So if this nebula here is too close to this star, so the energy and the light from this star is so strong will blow away, will evaporate this globule. And then what? This is called a stellar miscarriage. A star and planet that fail to form. But if this star is a bit not so powerful, so this globule made of dust and gas will collapse successfully to form a star. So it doesn't mean that every single globule will successfully form a star, a new star. If it's in a place where the stellar wind is very strong, it may be evaporated away. So it's a stellar miscarriage. But looks like it, this star here is not very energetic, so it will survive. So maybe in future, exoplanet will be formed, star will be formed. And remember, in our Milky Way galaxy, near to the sun, we have discovered about 5,000 over exoplanets already discovered. All right. So this is our stars and globules in the running chicken nebula. Okay. We go to the next one. 17th of April. Now, it looks very simple, but I like this, you know. And I hope you will bear with me. I'm going to play a video. So basically, this was many years ago in Expedition 22 crew, right? The Space Shuttle Expedition 22 crew, and that time in the International Space Station, the what we call Space Shuttle Endeavour has been launched from Cape Kennedy, and is slowly chasing what? Chasing the ISS, and sometimes going closer to the ISS, it becomes bigger and bigger, right? And so you can see here is the Earth, and then you have the troposphere, is the lowest part of the Earth's atmosphere, touching the Earth's surface, and stratosphere, mesosphere. Now, stratosphere doesn't mean Gunung Tahan height, you know, much higher than Mount Everest. Mesosphere is close to like space, and Endeavour is coming closer and closer, right? And it's indicated here that actually this part here, where the Earth's atmosphere is 2% of the radius of the Earth. Remember, the radius of Earth is about 6,400 kilometers radius. So the diameter is about 12,800 kilometers, right? So I always tell my students, USM, that do you know how big is the biosphere? What's biosphere? Biosphere is the Earth's atmosphere, the water in the ocean, and the land where people can survive, all right? So this is called the biosphere, where things can survive. That is the land, the water, the ocean, and this atmosphere. So what is the size of the biosphere? Some people say, I thought the Earth's atmosphere is very big. Not true. Imagine that you take a sun-kissed orange, you dip it into coconut oil, and immediately you take up the sun-kissed orange, a thin layer of coconut oil will surround the sun-kissed orange. That is the relative thickness of the Earth's surface, the water, and the atmosphere. So actually, the biosphere is very, very fragile, very thin only. So this is, in a sense, the atmosphere, and actually most of the biosphere is the atmosphere. So that's it. And so now you have this Space Shuttle Endeavour is coming closer to the International Space Station. All right, and we'd like to play a video. Whenever I see ISS or another spacecraft in space going to approach by another spacecraft to dock, all right, I always remember this movie. Remember, I was in USM in the 1970s, but in 1968, a famous movie, 2001: A Space Odyssey, where they also call a shuttle spacecraft, was launched from the Earth, and they joined up with of course, this is a science fiction movie, with the Space Station 5. 1968 already got Space Station 5. There's a huge International Space Station, and the shuttle is docking with the Space Station 5. So if bear with me, I play the thing, all right? A Space Odyssey 2001, approach for what? The shuttle to this. So this is the Earth, this is the Space Station 5. So this is a shuttle hitting, going to attach to it, and this is a big object, no? That's the Earth. I really like this part of the movie. I just stop. Now, the diameter of this double wheel, the diameter of this is 300 meters. So inside this big circle, you can put in 9 football fields. All right. So at this will rotate at a certain what you call speed, so that at the rim of it, it maintains 1g. So as people can survive there with the all pressurized compartment, no need to wear a spacesuit. And this whole space station part is orbiting the Earth. The space shuttle is going to join with Space Station 5. This is in the Space Station 5. No, this is in the shuttle. The Space Station 5 there. So the shuttle is come to land in this Space Station 5. But look at how big it is. There you are, the space shuttle joining with the Space Station 5. Okay, wait a minute. So Rayan, you thought that our ISS is very big. This was in 1968. So I saw this movie in an early 1970. Was doing bachelor degree in USM. So I told myself, I hope this will come true. I thought science fiction may not be, but now in our lifetime. Remember, China want to make a big space station, no? But the space station is long. I hope they make in the form of a wheel, and spin it. So this could be in our lifetime. So whenever I see two spaceships attaching, especially a spaceship, the Russian Progress spaceship, so and this what you call this SpaceX, Dragon Crew joined with the ISS, I would think of that movie. All right, that's it. So now we go to the next one. No, now is Bunwei,
Yeah. Next is me.
Uh,
Yeah, let me share my screen first. Okay, so whether is it can see my screen already?
yes,
Yes, we can.
it's nice.
Okay, so actually this one very very clear, and actually I think is once you see this, then you can already know it's actually from the Orion constellation, and this photo is actually taken by Juan Carlos Castro. He's an amateur astrophotographer from the TWAN organization, and this is actually taken in I think it's almost the time from this because now the Orion is also setting, and this is actually showing the setting Orion constellation. So from this photo, so you can actually see this three Orion belt, and also the Frame Nebula, and somehow the horse head nebula can clearly shown on this photo, and below this below the belt you can also see the Great Nebula of the Orion, and it's actually very easily under a very, very dark sky, you could actually see it with the naked eyes. But actually, somehow from Penang, I can only see the two stars. Like I couldn't really see the nebula under that. And also, you can see the Bernard look of this. I mean, from the Orion molecular cloud complex of this. So this is actually a very, very beautiful image, and you can even see there is a very, very how to say, is you can see a light bulb. It's actually not a light bulb. It's actually the Orion bright blue giant super giant regional stars. Is on the is so how to say, so ngam is on touches the branches of a pine tree. It's like part from this pine tree. So yeah, this photo is actually taken from the very I think it's in a rural village at Spain, and they, over there they got a very, very dark sky. So this is just taken by a camera fixed to a tripod, but to get this big Orion should be it should be like the telescopic lens already lah. Yeah. So move on to the next photo is
Bumi, I just add one thing.
yeah.
Looking at this picture, I can confirm that the air is very, very still. No wind, no wind. Because this is a long exposure, no? You need to expose it for a few minutes. And if there's any wind, the trees need to move. And then you find that the trees will be blurred out, but very sharp. The trees are very sharp, the branch sharp. No wind, very steady. Okay.
Yeah, the weather over, I think outside there is actually is much clearer and also more dry over there.
Yes, sir.
Yeah. Okay, so move on to the next photo is on the 15th April. So this one is actually taken by our NASA Curiosity Mars rover, and this is actually at the mouth shut from the Mars, and the Curiosity is actually exploring this mouth since 2014. So I think the researchers named this the wind-shaped rocks as the gator back rocks, and these rocks actually I think have the incidents happened from the Mars on the Curiosity that is actually making the damage to the rover's wheels. And so now the teams actually they are trying to use other routes to avoid to avoid the damage to the rover's wheel. And so the new routes that the rovers that will continue to explore the mouth shot with, actually the mouth shot is 5.5 kilometers tall mountain at the Mars, and the Curiosity is actually studying the sedimentary layers that shaped by the water in the Mars for this. And the making of the mouth shut is actually from the sediment and carried by the water and the wind that eventually filled with the crater floor layers by layers. So after the sediment hardened, then making these rocks and towering the mouth shut. So each layers that the Curiosity would like to, discover or study the layers is actually can also study with the environment or the environment on the Mars, and different layers got different, also explain the different era of the Martian history. So this layer, like if they study more in these layers, maybe they could find, understand more like the microscopic life, whether it can survive in the ancient Martian environment, because previously they could have the water. And the microscopic life, I'm still remember that's one chapter of the Doraemon comics is actually also saying that the mouse got the life, and also is got the aliens, like the aliens looks like a mushroom head and something that with a claw, like maybe like a jellyfish also. So I actually very very looking forward if Curiosity could get more study in it, and also hopefully they can really see that any life on the Mars. But I think no maybe God, maybe no, I'm not sure. Okay, so moving next photo is on the, okay, so I moving to the next photo is the 13, and this is a very, it's a very very wow photo that I, once I see this, it's like a movie scenes, like movies, one of the movie scene, like the something like, because this is the Devil Tower, right? So it's
Your
a
screen did not change, yeah?
eh
Yeah,
still
we're
on
still
15.
on the April 15th tape.
oh, okay, sorry. Maybe I just do the 13. Okay. Yeah, so this photo is maybe I have to zoom out to see the clear the whole picture. So this is like a movie poster. The photo is very very wow, and like just like a movie photo.
We are still on the 15.
Eh? I already seen is a 13 or sure. Maybe I just stop and then try
Yeah.
again. Uh-huh. Mm, sure. Okay, so this one can see now.
Can see.
Yes.
Yeah.
Yes.
Yeah. So this is a, I think I mean this one, this photo is a very very movie-like photo, movie-like poster. And this is actually the taking the Milky Ways and also the Devil Towers in US. So Devil Tower is actually I think it's like about 264-meter rock formation in in US, Wyoming.
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 Yes.
Ah, Wyoming. Okay. So they actually they was like the formation of this tower is still under debate, and they actually make the hypothesis that this is actually from the hardened lava, lava, and then but haven't reached to the volcano. So because of the erosion of the winds and uh also the strong winds and water, so making it looks like uh look like this, got like many uh rocks, and then and also uh making it like a hexagonal. It's actually a hexagonal shape of this volcano or mountain, or just Devil Tower lah. Yeah. So so this one is the very this is a Milky Way. So you can actually see many like Pipe Nebula and also the Radius Lagoon Nebula at the tower, right? So and the foreground, and making it like you are, going to the way of this of the heaven or something, just like tower, devil tower, and then the dark Milky Ways. And it, even actually the one this devil tower and also can also you, if you want to do the adventurous, you can also try to hide this devil tower. This is for the crack climbing area, and because of the crack in the devil tower is very in the length and also the width, so some is actually you can fit into it, and also you can, I mean, hide it. Because I'm not sure whether I got some photo with the climbing. I should share my whole screen actually. Yeah, so you can actually climb this devil tower. You can see this. I think they are actually climbing like in between. This looks so dangerous because
You
it's
want to try?
small. Huh?
Your legs must be long enough.
Yeah, I see
Yeah.
the legs is like can wide enough to put it in, fit in between the cracks. But the tower is so straight that wow, it's so, I feel so dangerous. Yeah. So okay, so moving next is
Wait a minute. Moment, you should go back to the Devil's Tower. I'll just add on. Huh?
yeah.
Now, you mentioned in the beginning the movie, The Close Encounters of the Third Kind, the famous movie in the 70s. So it was a blockbuster around the world in Malaysia.
Uh-huh.
Many people in Malaysia saw it. They were super awed by this. Awesome, right? So in the movie by Steven Spielberg, so it's the first encounter of alien landing. And the spaceship is a massive one, much bigger than the Devil's Tower, big one. It's as big as the one in Independence Day. But the Independence Day movie, the alien movie, I don't like because the plot is no good. But the plot for this movie, Close Encounters of the Third Kind, very well written. So it's Close Encounters of the Third Kind, the aliens came down to the Earth. That is a movie, famous movie over Devil's Tower. This is the one.
Oh really? Yeah.
Yeah,
Which one?
Yeah, Close Encounters of the Third Kind. The director is Steven Spielberg. Yeah, this is the one. Famous movie. He saw it many times.
Yeah, maybe I should go watch this movie.
Watch this, yeah.
Very nice. I mean, this scene is very nice for the movies as well.
Yes, yeah.
Yeah. Okay. So moving to the next is the 11. Okay.
Yes.
So moving to the next is the okay, is actually the taking the sun, I mean solar activity photo, and you can also see this small is our international space station is passing quickly, and also you can also see this sunspot and many sunspot, and also the I mean the prominence on the sun surface. So this photo is actually taken by the Wang Letian. I think he is a amateur astronomer from Beijing, and taking this at the noon time on the 2nd of the April. So it's actually very unusual that to take this IS is crossing so at the right time to crossing from the sun. And actually from, I mean, to the relative to the sun, our IS is actually small Dr. Chong.
Yes.
Okay, so I pass this to the next person.
Yes. Okay, let me share my screen. One moment. Okay, can you see my screen?
Yes, Ryan.
Can you see this?
Can see this is approaching now.
Okay, good. Let me get back to the APOD. Okay, the next APOD is for April the 6th of Arundel, half elf, half human, from Tolkien's Silmarillion, 1977. Is not what this image is. No, this image shares the same name, but it is of possibly the oldest stable star we have found,
Wow.
having existed 12.9 billion years ago, when the universe was only about... Can you hear?
No, you're not showing the pictures, but you are showing the list of APOD
Yeah.
on April.
You are showing the list. Click on the list, the date.
Oh,
Date
okay, wait.
the 6th of
Let me
April. Then you
stop
come.
presenting.
6th of April.
Can you see the screen now?
Go to 6th of April. Click on it. That's it. We got it now.
Okay. Arundel, yes. Possibly, as I said, the oldest stable star we have discovered, with what we call a redshift of 6.2, meaning it would have existed 12.9 billion years ago. The light we see is how it was 12.9 billion years ago. It is estimated to have around 50 to 100 times the mass of the sun, and to be over 20,000 Kelvin, which is over 36,000 degrees Fahrenheit. Now, there's a lot to go through, so I'll start off with the credits. Now, this image was taken by the Hubble Space Telescope. So, as usual, it is credited by NASA and ESA. But let's focus on these names here. From the Johns Hopkins University is PhD candidate in astronomy and astrophysics, Brian Welch. He discovered the star and gave it its name. Now, from the Space Telescope Science Institute is Dan Coe. Brian Welch is actually Dan Coe's graduate student. Now, the Space Telescope Science Institute works closely with NASA and has a base in the Johns Hopkins University Homewood campus. So that's why they're so close together. And then you have Alyssa Pagan, who helped with the processing of the image together with NASA and ESA, also from the Space Telescope and Science Institute. Now let me get to, can you see this? I am on the drawing page. Can you see the drawing?
Yeah, I can see a blank. Yeah, I can see it.
Okay.
Draw.
Now, what Brian Welch was doing in Johns Hopkins University was studying gravitational lensing of large objects. So gravitational lensing is a familiar topic in astronomy, where you have a very massive object in between, say, us over here. We're not actually in space, but I'll just draw a little stick man, and a smaller object in the foreground. So what it does is the light gets magnified and gets distorted due to the gravitational strength of this massive object. And that's what Brian Welch was studying in the Johns Hopkins University. Now, in this case, what we are looking at is the gravitational lensing of a large galaxy cluster. It's called WHL 0137 0-08. And it is of another galaxy, the galaxy in which Arundel is in, which is WHL 0137-ZD1. So that is the galaxy. And you can actually see the galaxy here. It's been nicknamed the Sunrise Arc because that is this arc over here. Now, as you can see, there's a magnification line. This is caused by the gravitational lensing. And in a rare case, when there is an object that is near or almost right on the gravitational, the curve line, or this magnification line, it magnifies it greatly. In this case, over 1,400 times greater, allowing us to actually see it. Usually, a star like Earendel would be hidden among star clusters in the galaxy. But in this case, because of its position, we were able to actually see it.
Wow.
Now, the previous star to have the previous oldest stable star was nicknamed Icarus, and that was only estimated to have lived 9.3 billion years ago. So this is much greater. We're talking about 12.9 billion years. Now, this line in technical terms is called a caustic, this magnification line, and it is the same reason you get bright light in a swimming pool due to the ripples and the waves on the surface. Now, by now, Earendel would have probably died. It would have actually definitely died, given that a massive star such as it only lasts a few million years, which is small compared to other stars. So, but there will still be other stars that were born during the same time as Earendel, smaller stars, less massive. They may still be around today. Now, the name Earendel, as I mentioned previously, was also partly inspired by J.R.R. Tolkien. He's the writer of the Lord of the Ring books, and the name Earendel means morning star. In the books, he's a seafarer who carried a jewel that was almost as bright, or actually as bright, as a star. Now, Brian Welsh, as I said, the discoverer, calculated that it is too small to be anything but a star, but of course there are other possibilities, and Hubble can only do so much. So it is hoped that when the James Webb Space Telescope comes online later this year, it can analyze Earendel further, perhaps confirm that it really is a star, and understand what it comprises of, what type of star it is. Okay, now let me move on to my next. Yes.
Just add on. First of all, well explained. You explained. Just add on that. So basically, this gravitational lensing was first proposed by Albert Einstein more than 100 years ago. So actually, when I see this discovery, I say always, Einstein wins again. A lot of predictions today, most of them have been proven true, but some of them not been proven. So this again, gravitational lensing, general theory of relativity by Einstein proposed more than 100 years ago, has been proven to be correct again. Yeah.
And with the James Webb Space Telescope, we may even be able to find older stars than Earendel.
Yeah.
Now, just one small thing. I forgot to mention this mirrored star cluster. That just happens due to the magnification line. So this star cluster here is the exact same as this star cluster, just being mirrored across. Okay, next APOD. April 3rd. Now this one is very interesting. What do we see here? We see a lot of colors that resemble those infrared images of heat. Well, they are of a certain spectrum of light, but not infrared. This is actually microwave. It is from the COBE satellite. I'm not going to go in the usual order. I'm going to start off here by mentioning the COBE satellite. That is the Cosmic Background Explorer, also known as Explorer 66. Now, it's operated and was built by NASA to analyze the cosmic background radiation, which is a defining characteristic of the Big Bang theory. It is basically a relic radiation that runs throughout our universe as a background or a backdrop to the other activities that occur. So COBE was made to understand more about it. So that's why you've got NASA here, because it was by NASA. And then you have DMR. DMR refers to the differential microwave radiometer, which is the instrument that took this image. And it actually found tiny variations in what was thought to be an almost uniform, almost literal backdrop of the CMB. It was thought to have around the same temperature. DMR showed that there were tiny variations in the temperature. Now, what you have here, this dipole, as called, Cmb Dipole, speeding through the universe. When we first saw this, we didn't know what it was. So what is it? Well, this was taken from a satellite that was orbiting Earth. Now, if you're sitting at home you think that you're stationary. You're just sitting on your chair, sitting at home. Maybe you're driving or you're out, in which case you would be moving, but relative to Earth. Now, what if I told you that even when you are staying stationary, not moving at all, you are still actually moving? Well, that's because the Earth orbits around the sun. Let's move over here. So we've got the Earth here, and it goes around our much bigger star. This is not the real scale. This is just for the purpose of this illustration. So the Earth orbits around the sun. Then you might say, what about our solar system? Is our solar system stationary? No, it is not, because it is going around our galactic center. Again, not to scale, but our entire solar system is moving around the galactic center. Now, our galaxy itself is moving around in the local group, and our local group, it is traveling towards the Great Attractor. The Great Attractor is the center of gravity in our supercluster, Laniakea. If I'm not mistaken, is the pronunciation of this supercluster. So the Great Attraction is actually what you see here in red. Now, it may be a little bit counterintuitive, but as things get hotter, they get closer. And in astronomy and in physics, when things get closer, their light is blue shifted. While when things get further and get colder, as in this, its light is red shifted. So the blue stuff here are moving away from us, and the red stuff here are moving towards us. The Great Attractor is this red thing here. We are moving away from here and heading over to the Great Attractor. Now, our entire local group is moving at a speed of 600 kilometers per second, which you may think is fast, but given that the distance to the Great Attractor is around 147 million light years, it would take trillions of years for us to reach there, by which time the sun would have died, and hopefully humans will be on a different planet. Now, for my last APOD.
Yes. You started this figure. What is this figure? Straight away, I think is yin and yang symbol. But yin and yang symbol is black and white. They got color. Because yin and yang symbol look very similar to this. All right. In East Asia, they have a yin and yang symbol, very important. So this is the yin and yang symbol, the cosmic microwave background. Okay.
Yes, it is. Okay. And similar to this image, it is a dipole. You've got the black and the white. Now, wrong one. Okay. My last APOD, where classical meets modern. Everyone will recognize that this is the Leaning Tower of Pisa.
Yeah.
The famous place where Galileo is said to have done his experiment that showed the first law, for Newton's first law, and many other things that he discovered in classical physics, as of course what we call the father of modern science, Galileo. Now, before I get into the details of the image, let's have a look at the image credits. Antonio Tartarini. He is a photographer, and he credits himself on his Instagram page as chasing alignments of the sun and the moon with monuments and architecture, as you can see here. He loves photography and astronomy. Now, let me get to the image here. So Galileo, as I said, was partly responsible for Newton's laws of motion. He inspired them. And Newton realized that light can be broken up into a spectrum. Many sciences later and generations later, it was realized that visible light is only one part of the spectrum. We've got X-rays, we've got microwave, we've got radio wave. And we found out that the sun at certain times does have radio emissions. In fact, this image here, which was taken on March 27th, you can see, I think it'll be better if I use the APOD. One moment. You can see here that there is a sunspot.
Yes, I can see.
These are at
one.
Yes. These are at the active, the solar active regions 2975 and 2976. And this is where things get really interesting. March 28th came, day right after. And the SOHO spacecraft, the Solar and Heliospheric Observatory, which faces the sun, observed an eruption of 17 solar flares from the sun.
Whoa.
Now, 11 of them were what we call C class. Oh, no, that's not class. C class. These are relatively minor. They don't affect the Earth that much. Now, 6 of them were M class. M class creates magnetic disturbance and short radio blackouts at the poles. At the same time, together with these, were 2 coronal mass ejections. So some pretty serious stuff happened on the 28th, and all of these resulted in something on March 31st, when there was an aurora and a geomagnetic storm at the poles. Now, a day before that, March 30th, we had something truly spectacular. There was an X-class solar flare. Yes, X-class solar flare, the type of solar flare that creates global radio blackouts. So on the 30th of March this year, there was a global radio blackout due to an X-class solar flare from the sun. And this teaches us something truly amazing. Oftentimes in physics and in science and the universe, some of the most violent things to exist are often some of the most beautiful. Thank you.
Yeah. Thank you, Ryan.
Thank you, Dr. Chong.
So the next one is 10th of April. Can see the screen, huh? Ryan?
Yes, we can.
Okay. So we look at this a big picture. Later on, I'll use the slide. Wow, looks interesting, huh? What's this thing? This is the moon. And then it's by NASA, Arizona State University, of course, the LRO. LRO is a lunar reconnaissance orbiter that is sent by NASA on a polar orbit around the north pole of the moon and south pole. And as you go from north and south pole and keep on orbiting the moon will rotate around it. That means once a lunar day, which is one lunar day is equal to 1 Earth month. Huh? So over the 6 lunar day or 6 Earth month, as the lunar reconnaissance orbiter orbit the moon, it goes over the south pole of the moon and kept on taking, and you have this picture. So what is this picture? Let's use the slide. Interesting. Moon, now this is an astrophotography of the moon. And then you may say, why like that? So ugly looking. It's not the how it looks like, the meaning. Okay, the meaning is fantastic. So basically, the actual geographic south pole of the moon is over here. So black. That means that for 6 lunar days and nights, the LRO move over the south pole. It's always dark. That means it's in perpetual darkness, perpetual night. And here, this daytime is very bright. A lot of sunlight here no sunlight. And this one is a place called Shackleton Crater. Okay, named after Shackleton, an English explorer of this Antarctica. So this Shackleton Crater near to the south pole of the moon is also dark. So basically, you just pass over the what we call lunar south pole, you don't see so much influence. Over 6 passes, 6 lunar days, so the effect is accentuated, is exaggerated. So here, very dark Shackleton Crater. Yeah. So that means that if ever you want to explore the moon, you know that here is very dark. Whenever you have dark what? Water. Remember, the Americans and Russians have orbited the moon, the orbiter, and with this equipment, they detect that on the moon, in the north polar region of the moon and the south polar region of the moon, got water. Not in the form of liquid water, but below the surface, maybe in the form of frozen ice. So the moon got, so maybe here, this polar region of the moon, on the crater floor, should have a lot of ice. And here also Shackleton Crater. So here the dark area we have ice. And the object here is the bright area here. So maybe if the man want to colonize the moon, you can put a solar cell there, because this is in the South Polar region. So this part is mostly in daylight. For one whole lunar day is in daylight. So here you can put your solar cell to collect solar energy, and here you can get water. So very nice, you know. So you may say, I thought the moon should have a nice lunar crater and the sea. No, this is a picture of the moon by Lunar Reconnaissance Orbiter, showing where the places where very dark, where you may have water, and the places which is very bright, that you can put your what they call solar collecting device there. Okay. So the next one is 7th of April. Okay. So let's increase the size so that you can see first. Sagittarius star crop, of course, in the constellation of Sagittarius, Messier 24. And Messier 24 is one of the rare Messier objects, because really usually Messier objects are star clusters, nebula, galaxies, but it's not. It's actually a gap in space, this area with some stars, by Gabriel Rodriguez Santos. Okay, it's a kind of what they call just only 22 years old only, studying in university, all right, Sao Paulo, Brazil, all right, and it's literally this gap, and then you can see this what they call this dark nebula, absorption nebula, all right, and so on. So a lot of things. So you are looking at towards the center of the Milky Way, because it's in the direction of Sagittarius, Messier 24, all right. So basically, is that here they are full of stars. The center of the Milky Way is full of stars, and many places in the world, including Malaysia, in the darker area outside the city, you can see many of these the Milky Way center, and of course this is part of it. It's actually one of the star clouds in the Milky Way center. But this is not where you have the Sagittarius A star, the supermassive black hole. It's a bit away from this what I call place. So we go to the last picture. 2nd of April. Okay, this we have discussed many times, but never mind. It appears all the time. And Aurora, Nova Scotia, Northern Lights, right? So Nova Scotia is an island, easternmost part of Canada, not in the North Atlantic Ocean. And this, because it happens in the Northern Hemisphere, it is a Northern Light, or Aurora Borealis. So if it occurs over Argentina and this Australia, it will call the Southern Lights, or Borealia Australis. But this is Borealia, this is the Northern Lights, all right? And you can see this thing here. And then this is taken by our Jason Dane. It's a landscape, wildlife, night sky photographer, all right? And then you can see that it's very simple. Just you see this there, camera stand on the ground, camera on the stand. You expose it for a few minutes, I can see different colors. Why different color? Basically, the sun is active and it emits those solar wind particles. So solar wind particles are the electrons and the protons, the charged particles. And they travel from the sun very fast, traveling about 500 kilometers per second. And when they reach near the Earth is covered in a cocoon. The cocoon is the Earth's magnetosphere. I mean, because in the center of the Earth is a liquid nickel and iron. In the center of the Earth, liquid, hot. And because of that, there's a lot of current, charged particles in the Earth core. And this Earth core is moving. And when the charged particle moving, it generates an electric field. The electric charges moving in the Earth's liquid core, the hot core, it generates a magnetic field. This is a magnetosphere of the Earth. And the magnetic field from the center of the Earth will pass through the Earth's surface into space, thousands of kilometers space, and come back. So this is the Earth's magnetosphere. And the Earth's magnetosphere, the magnetic line, will converge in the north geographic pole and also the south geographic pole. So if you have this charged particle from the sun, the solar wind, after the say a solar flare or coronal mass ejection, like what Ryan said earlier, it will hit the Earth's what they call atmosphere in the equator. So in the Earth's equator, the Earth's magnetic line is perpendicular to the direction of the flow of the solar particle. So this one, the Earth's magnetic field over the Earth's equator, over Malaysia, will deflect the charged particle away from the Earth. So we are protected by the Earth's magnetic field over the equator. But near the North Pole, the North and South magnetic lines will converge to the North Pole or South Pole. And as they converge, the what we call the solar wind particles, the charged particle from the sun, will follow magnetic line and will channel into the, and will be focused, concentrated in the North Polar region or in the South Polar region. So now in the North Polar region, the charged particle will hit the upper atmosphere. So this aurora do not occur 10 kilometers from the Earth's surface. No, much higher, close to space, where there are air molecules. So the electrons and the protons will not collide with some of the oxygen and nitrogen molecules, and it will make them excited and will kick out some of the electrons from these molecules. And with these electrons that are kicked out, they have those so-called energy levels have been emptied. So later on, the upper level will fall down to fill in those electrons that be kicked out. So as they fall down, they will give off light. And depending on the what you call the electronic state that has been repopulated, it can give off different color. So basically, this color red is not the red from your traffic light. No, the traffic light of your car in the town is actually LED, quite similar. But the normal red you see, let's say you have a light shining on a red piece of paper, you see, is continuous wavelength red. Now this is not. The aurora is discrete lines, emission line, discrete line. So if you have a spectroscope, you look at the red line, the green line, and so on, the blue line, they actually have discrete bright lines. Next to the two bright lines, they are dark area. So this is actually the discrete emission lines of the aurora. It's very nice. So just put there and so on. Well, of course, a lot of people also will record this, the sound of this aurora, because when you have this solar wind hitting the Earth's magnetosphere, it will interact with it and it can give off low frequency radio wave. So how to listen to it with a radio or a radio telescope. And you have those, I'm going to imitate how it sounds like. Hear the aurora. So you don't only see the aurora with the camera, listen to aurora. Sounds weird. Like this, right? You can hear it, you can see the aurora. But it's over Nova Scotia. But unfortunately, in Malaysia, we are far from the north and south pole. We are near equator. So we are waiting for Orion 2025. Why? Maximum is 2025. So in 2025, the sun will, what you call, faithfully fulfill its 11-year cycle. 2025, sun very active, a lot of activity. We hope to be able to see. Because I remember in 1991, 92, I read the sky in telescope. People in Singapore photographed aurora. Yeah, Singapore, 1990, 91, they took picture of aurora. That means the aurora was very active that time, 1990, 1991, peak of the solar cycle. So the aurora spread from the North Pole and the South Pole until practically the whole globe was enveloped in aurora. Of course, North and South Pole more intense, but reach the equator not so intense. But if you have a camera, there's an aurora in the sky, you expose it for a few minutes, you should be able to see. I remember some years ago, our member, Mr. Teo Sim Beng, is a well-known amateur astronomer from Bukit Matajam, but is now migrated to KL. He came back from Nepal, I think about more than 10 years ago. He showed me a picture. He said, why? Above the Himalayas, there's a pink glow, quite bright, the pink glow. But he said he saw his own eye. No, dark. Then 1 week later, he came to see me again. He just said, he's confirmed that it was aurora. He captured aurora over Nepal, over Himalayas. Where his eye cannot see, his camera could catch. So we are hoping that you can see aurora in 2025. So keep your hands, your fingers crossed, okay? For aurora, okay? So I think that's all. Live. Now let me see. So just wrap up. So well done, everyone. Live.
Yeah, so I think from the both Facebook and YouTube, we don't have any questions. So I think maybe we can close the session. So Dr. Chong, closing remarks.
And then just to announce to everyone who can come to see this later, the next event. So Ryan, next event, I don't know whether you saw our members of the group that 12th of May, big announcement.
Yes.
Number two. Remember, 2019, they imaged the supermassive black hole in M87, which is about 5 million light years away. But I suspect they never give any secret out, because I was told that there's an embargo by European Southern Observatory that no astronomer involved must reveal it. Only will be revealed during the press conference. Press conference by European Southern Observatory, 12th of May, Malaysian time is 12th of May this year, 9 p.m. Malaysian time. Okay, so we announced. So I need a guess that what is the Event Horizon Telescope doing? It makes a black hole. So no other black hole in Milky Way but in the center of Milky Way. Sagittarius star.
Yeah.
I think they will announce. So we hope that they will announce the image of the black hole. Remember, I'll show you now the black hole, and then some information on the black hole. And of course, after that, what? Look at the other neighboring galaxies. So remember, the earlier, many years ago, when I came on astronomy, many years ago in high school, it was like this. Hey, they proposed that this thing cannot exist. Then later on in the 1980s, they said one or two neighboring galaxies got black holes. The signature is X-ray. So the black hole in the center of Milky Way was in the late 1980s discovered. But that was the case. But now the cosmologists have the idea that the process of getting a black hole is a certainty. Any galaxy in the universe must have a black hole, supermassive black hole. That's confirmed. But there's still an unsolved mystery. Did the black hole come before the galaxy was formed, or did the black hole form after the galaxy was formed? So they are still working on it. So that's interesting. So in a sense, those people who are listening to gravitational wave, big discovery. Remember, 2016. There are many gravitational waves passing through the Earth every day.
True.
They are saying that if the LIGO detectors around the world up to peak sensitivity, and they add more of these LIGO detectors in India, in Japan, every 5 minutes there should be a LIGO detection. Every 5 minutes. So don't know what to analyze, too many. But to look for image of a supermassive black hole, harder, because you have to find it in center of galaxies, all right, so on. And because you may say, in our Milky Way, according to astronomy, 200 million stellar black hole, not the galactic size, stellar black hole. So why don't you observe? There are problems, right? Because you see, the one in M87 in 2019 that they saw the supermassive black hole, because it's a 6 billion solar mass black hole, 6 billion. So the event horizon is big, huge. So all the particles that swirl around by friction to give off the radiation, they will move because it's a huge sphere. The speed around it is slower. But this Milky Way supermassive black hole is only 4 million solar mass. It's much smaller. So the material swirling around is faster. It's not easy to take. Why? Because Event Horizon Telescope is an area of telescope all around the world, especially in America, Europe, and Hawaii, and in Greenland, and in South Pole. So all of these look at, let's say, supermassive black hole in central Milky Way at the same time. So I said, we do that, okay, Hawaii is going to look at this supermassive black hole for half an hour. So all the other EHT telescope must look at the same time. What about, let's say, over Hawaii, the weather is good, but the other places, weather is bad. The weather must be good. So it's very, everything must be very chancy, very, very touch and go. Weather must be good in all these places, and all must point to that Sagittarius center, and at the same time image it. So it's not easy. So we hope a list of supermassive black hole image will come in the center of galaxy. Maybe later on, human being can take the supermassive black hole image of stellar black hole. That's harder to do because the stellar black hole, the material that's swirling is faster. But remember, when you look at the M87 black hole, when you look at it, because it's so far away and the event horizon is so big, so the velocity is not that fast. So if they expose it, the telescope on the Earth for say 1 hour, half an hour, it doesn't move much. But once it moves, it becomes blur. It shouldn't move. Now, let's say black hole in central Milky Way is smaller, so it will move. So I don't know how they overcome this problem. I was thinking how.
It'll be interesting to see.
It'll be interesting, huh? And then,
Yeah, Dr. John, I think we end the session first.
Okay. So we end now. So thank you, Lai, for introduction. Thank you, Michael, for hosting. Thanks to Miss Flower. Thank you, Ryan.
Thank you.
Have you with us.
Thank you.
Yeah, so I think, yeah, we see you in the next month, next APOD session in May. So do join us, subscribe our page, and follow our Instagram and Facebook for more information. And I think that's all for tonight. Thank you, everyone. Have a good night and Selamat Hari Raya.
Thank you.